So before we can even get into web application hacking, we got to figure out what a web application is. So web application is software that runs in a web browser. Unlike the traditional desktop applications, it relies on client-server architecture. The client is typically the user's web browser, and the server handles logic, data processing, and storage. So, some examples of this would be your online banking portals, e commerce platforms, and learning management systems, as well as webmail. The web applications are built using a combination of technologies, one of them being like the front end application, HTML, CSS, and JavaScript. It's what the user interacts with. The backend can be written in like PHP, Python, Node.js, Java, and other languages. And then the database portion would be SQL or NoSQL based. So like MySQL, PostgreSQL, or NoSQL being the MongoDB or Firebase. These apps accept user input processing and often store or retrieve data from the backend system, making them prime targets for attacks if not properly secured. Now we're getting into the OWASP Top 10. So what are they? Well, it's part of the open worldwide application security project that maintains a list of top 10 most critical web application security risks. So we got our broken access control where users can act outside their permissions, cryptographic failures where weak or improperly implemented encryption exists, your injections including your SQL, NoSQL, OS, and LDAP injection attacks, insecure design where you're dealing with architectural flaws that lead to vulnerability, security misconfigurations where default settings exist, unnecessary services, or exposed error messages. Your vulnerable and outdated components where you're using libraries or plugins with known vulnerabilities, identification and authentication failures where you have poor session management, and brute force exposure. Your software and data integrity failures where issues like unsigned code or insecure CI/CD pipelines exist. And security, logging, and monitoring failures where you have inadequate detection or response mechanisms in your server-side request forgeries, SSRF where you're exploiting a server to make internal requests. So what is or what are SQL and NoSQL injections? Well, SQL injections are a type of input manipulation attack where an attacker inserts malicious SQL statements into an entry field like a login form or a search bar in order to gain unauthorized access to the database. Your NoSQL injection is where a NoSQL database such as MongoDB or Firebase, which don't use traditional syntax, can be still exploited through unsanitized inputs. But what are the risks associated with these type of injection attacks? Well, we've got data exfiltration where an attacker can dump an entire database. Authentication bypass where you log in without valid credentials. Your data manipulation where you modify or delete records. Privilege escalation where you gain administrative access. Denial of service or DOS where you use resource-heavy queries to crash the system. Persistent backdoors where you plant hidden admin accounts or scripts. So for NoSQL, the risk can be a little bit broader since the input structure may be less strict and developers may assume safety where none exists. But how has AI and cloud impacted this? Well, with AI, you have AI-based query builders. So if they're not hardened, AI that generates database queries on the fly, such as your chatbots, natural language to SQL tools, may introduce unsafe patterns. Model drift and injection, where AI models trained on improperly validated data may unknowingly learn injection patterns and reinforce them. And then your synthetic testing tools, where red teams use AI to auto-generate exploit payloads based on known weaknesses in an application, which increases its attack surface. Cloud's also impacted it by increased exposure because cloud native apps often have APIs or public endpoints by default, which may be insecure. Your lack of segmentation because of a vulnerable microservice in a cloud app can grant access to other services if not isolated correctly. And that's serverless risk, where in environments like AWS Lambda or Google Cloud Functions, vulnerable function code can be exploited for injections without traditional server access. And you have your shadow databases. With easy provisioning, developers often leave test or development databases exposed unintentionally, which invites attacks. Now it's time to get your tools ready. So we have WebGoat, DVWA, Kali Linux, and we're going to be using Python 3. We're going to do this for demoing our base64 decoding, which is the first one. And then our XOR encryption, where we're going to use a Python script to brute force it. And then plain hashing, where we're going to use John the Ripper in order to, again, dictionary attack two hashes, one of them being MD5 and the other one being SHA-256. Here we're going to be doing a SQL injection and a SQL blind injection. And the tool we're going to use for a blind injection is going to be Burp Suite with Intruder. And we're going to essentially brute force that blind injection.